For this lesson, we're doing Module 4, Lesson 13. For this lesson, we're really just going to focus on some vocabulary words. And the first vocabulary word we're going to focus on is this word equilateral. Now, all of these words we're going to be talking about today are going to be dealing with triangles. So to start with, we have an equilateral triangle. With an equilateral triangle, all three sides are the same length. So an equilateral triangle, all three sides are the same length. Again, I'm going to write pretty quick today. If it's too fast for you, remember, you can always pause the video and go back and look at it again. So I'm going to start by just making a basic triangle. I'm going to make a better one than that. That's pretty bad. So basic triangle. I'm going to mark them each with just one line to show that each side is equal. When you see that, that means that each side that has just one line is equal to each other. So all three sides are equal in length. And I'm going to just write down a measurement because you will see this a lot of times. You may have to measure or the measurements may be given to them. So all three sides equal 3 centimeters. So equilateral, all three sides are the same length. Also, when we talk about equilateral triangles, we have acute triangles. So in an acute triangle, all three angles are acute in the triangle. So if I look back at my triangle I have on the other side, just going to use a different color so you can see. So we have this angle, which is acute if we put a protractor on it, or you should be able to look at it by turning your sheet. This angle is acute, and this angle is acute. So when all three angles are acute in the triangle, it is an acute triangle because it has all three angles that are acute. The next type that we'll be talking about is an isosceles triangle. An isosceles triangle. Two sides have the same length. So two sides have the same length in an isosceles triangle. So just going to sketch a triangle. This side and this side are equal. This is 4 centimeters. We're going to call this 4 centimeters. And this bottom side is 6 centimeters. Notice where each side where I have 4 centimeters, I have two lines that's showing that those two sides are equal. So again, isosceles triangle, two sides have the same length. In this picture, each are 4 centimeters. Now, we're going to talk about, when we talk about angle measures, we're going to talk about a right triangle. So in a right triangle, it's a triangle that has one angle that is a right angle. And again, remember, right angle is just a 90-degree angle. So we have one angle that is 90 degrees in my triangle. So when I automatically have one angle inside the triangle that is 90 degrees, it's automatically a right triangle. It does not need to be an isosceles triangle to be a right triangle. For the next one, we have the vocabulary word, this word scalene. In a scalene triangle, this is probably the easiest we will see. All three sides have different lengths. So scalene, all three sides have different lengths. I'm going to sketch a scalene triangle really quickly for us to see. We're going to label it so we have an example. So I'm going to put one dash here. This side is going to be 3 centimeters. I'm going to put 2 up here, 9 centimeters. 1, 2, 3 to show that this is its own side, 11 centimeters. So if I look, I have three side lengths. I have 3 centimeters, 9 centimeters, and 11 centimeters. So all three side lengths are different, so it's a scalene triangle. Now, for a triangle to be an obtuse angle, the triangle has an obtuse angle. So it has an obtuse angle. If I look at my triangle I sketched over on my left, I should be able to see, just by eyeballing it, that this angle right here is acute. This angle over here is acute, so that's acute. This is acute. Now, if we remember, all three angles must be acute for it to be an acute triangle. If I look at this angle up here, though, and I actually turn my shape or turn my sheet and put a protractor on it, I would find that this is obtuse. It'll be much easier when we draw our own because they'll be much bigger. So if it has an obtuse angle, it would be an obtuse triangle. The triangle has an obtuse angle. It only needs to have one. For a right triangle, it just needs to have one 90-degree angle. And for an acute triangle, all three angles must be acute. So we will just keep working on these vocabulary words as we go. Now, here's more of what we will see normally. So the directions say, classify each triangle by its side lengths and its angle measurements. Circle the correct names. So in the first part, we're just going to do the side lengths. So I'm going to start right with A where I just circled. So if I look, I have two lines that are matching, which tell me that two sides have the same length. So I'm going to go back and look. A scalene, all three sides have different lengths, so that is not true. Isosceles, two sides have the same length, so that is true. So this is an isosceles triangle. Now I'm going to look at it. For it to be an acute triangle, all three angles must be acute. This is acute, this is acute. If I look at this one right here, I should notice it's an obtuse angle. So because I have one obtuse angle, it's an obtuse triangle. Now for the next one, we're going to look. We have 1, 2, 3 sides that are the same length. I'm going to go back and look again. Scalene, 3 sides have different lengths. Isosceles, 2 sides have the same length. Well, I have 3 in this one. So all 3 sides are the same length. It's an equilateral triangle. I'm going to circle equilateral. Now, I need to classify using angle measurements. If I look at the angles, so I have 1, well, that is acute. I can tell by looking at it, or I could put my protractor on it. This angle down here is acute. You can look at that. And this angle right here is acute, so I have 3 acute angles. So when I have all 3 angles that are acute, it's an acute triangle. Now for C, something should jump out at you right away. Should be this little box in the corner, which tells us we have a 90-degree angle. So I'm actually going to start with classifying using angle measurements first. When we have one right angle, we have a right triangle. Pretty straightforward. Now if you look at this picture, there's no dashes or there's no lines drawn at any of the side lengths. So what that's telling me is, so if there's no lines, and I'm not measuring it, so if there's no lines and you're not actually measuring it, there's three side lengths. So if there's no lines, there's 3 different side lengths. So we have 1, 2, 3. And if we actually put our ruler on this, we would actually find that there are 3 different side lengths. Now, I need to look at what kind of triangle I have. So I have 3 different side lengths. It's not equilateral. Equilateral, all 3 are the same length. Isosceles, 2 are the same length. Scalene, all 3 have different lengths. So the answer is a scalene triangle. So we have a scalene right triangle. For the next one on D, this looks a lot like our example. So if I look, I don't have any lines drawn. I'm just going to go ahead and put these in to help me. So I have 3 different side lengths. When I have 3 different side lengths, none of them are the same, I have a scalene triangle. Now I'm going to come over and look. For it to be an acute angle, all 3 angles have to be an acute. Well, this one is acute. This one is acute. I can tell from here. If I look at this one up at the top, and I would actually turn it, put my protractor on it, I would find that is an obtuse angle. And I can tell that that's not an acute angle, so it can't be an acute triangle. And I don't have any 90-degree angles here, so it can't be right. So the only other choice left is obtuse. So give this your best shot tomorrow in class. We're going to spend a lot of time reviewing these vocab words. We're going to spend time drawing some angles with our straight edge. And we're going to spend some time actually drawing these triangles and looking at them, turning our sheet so we can see, is the angle acute, right, or obtuse?